Welcome to Data Engineering with Subhadip. Today we embark on an exciting journey into the world of change data capture, or CDC. We will uncover how CDC helps unlock real-time data for your data pipelines. So what exactly is change data capture, or CDC? At its core, CDC is a set of design patterns to track data changes in a database. It is crucial for real-time data integration and data warehousing. CDC captures only the deltas, which are inserts, updates, and deletes instead of full table scans. This enables low-latency data movement and significantly reduces resource consumption. Imagine it as a vigilant watchman for your database, noting down every modification. So why is CDC essential for modern data architectures? Firstly, it powers real-time analytics, providing up-to-the-minute insights for dashboards and operational intelligence. Secondly, it simplifies data replication, ensuring disaster recovery and read replicas are always synchronized. Thirdly, it's a cornerstone for data warehousing, enabling incremental loading into data warehouses and data lakes. And finally, it's vital for microservices and event-driven architectures, allowing database changes to be propagated as events to other services. Let's dive into the two primary mechanisms for CDC. First, we have log-based CDC. This method monitors the database's transaction logs like MySQL's bin log or PostgreSQL. These logs record all changes at a very low level. Its advantages include being non-intrusive, low latency, and capturing full transactions. However, its database-specific requires elevated permissions and involves complex log parsing. Second is trigger-based CDC, which uses database triggers that execute automatically on DML events. Its advantages are being more database-agnostic and offering granular control. The downsides are performance overhead, increased database load, and less robustness for complex transactions. Now let's look at some popular CDC tools. First up is Debezium, an open-source distributed platform for CDC. It integrates seamlessly with Apache Kafka and Kafka Connect, and is log-based. Next we have Maxwell, which reads MySQL bin logs and writes row-level changes as JSON to various targets like Kafka or Kinesis. It is also an open-source log-based tool specific to MySQL. Finally, we have Oracle Golden Gate, a robust commercial solution for real-time data integration and replication across various heterogeneous databases. It is also log-based. Let's explore a common and powerful real-time data pipeline, CDC to Kafka to Snowflake. It starts with your source database. A CDC tool like Debezium captures the changes from the database logs. These changes are then streamed to Apache Kafka, which acts as a robust message broker for all events. Finally, from Kafka, the data is loaded into Snowflake for real-time analytical processing and reporting. This pipeline ensures that your data warehouse is always up to date with the latest operational changes. Let's break down each component of our pipeline. The CDC tool, like Debezium, acts as the connector. It reads transactional logs, converts changes into a standardized event format such as Avro or JSON, and sends them to Kafka topics. Apache Kafka serves as the distributed streaming platform. It provides high-throughput, fault-tolerant, and ordered delivery of these change events, effectively decoupling the source from the destination. Snowflake is our target data warehouse. Data from Kafka is consumed either via a Kafka Connect Snowflake Sync connector or Snowpipe streaming and loaded into tables. Optionally, you can include a transformation layer using tools like Kafka Streams or KSQLDB for in-flight processing, filtering, or enrichment of CDC events before they reach Snowflake. Schema evolution is a critical challenge in CDC. Source database schemas can change, with columns being added, dropped, or data types modified. If not handled gracefully, these changes can break downstream consumers. The solutions involve utilizing CDC tools like Debezium, which often embed schema information directly within the messages. Coupling this with Kafka Schema Registry and Avro ensures strict schema enforcement and compatibility checks. For Snowflake, you can use variant columns for initial flexibility, or implement robust schema migration scripts to adapt your tables to schema changes. The example shows how a Debezium message includes schema and payload, demonstrating a column addition. Managing latency and ensuring robust error handling are vital for any CDC pipeline. While the goal is near real-time, actual latency depends on several factors: CDC tool configuration, like polling intervals and batch sizes, Kafka throughput and consumer lag, the Snowflake loading mechanism, whether it's snowpipe streaming or microbatching, and overall network bandwidth. For error handling, you need a robust strategy. Implement comprehensive monitoring and alerting to track connector health, Kafka consumer lag, and Snowflake load status. Configure retries and dead letter queues so that connectors can retry failures and unprocessable messages are moved to a DL queue for manual inspection. Finally, design downstream processes with ID impotency in mind to gracefully handle any duplicate messages. Let's summarize our deep dive into change data capture. We learned that CDC is vital for real-time data synchronization and significantly reduces resource usage. We explored the two main mechanisms: log-based CDC, which is non-intrusive, and trigger-based CDC, which offers more flexibility. We looked at popular tools like Debezium Maxwell and Oracle Golden Gate that enable efficient change capture. We understood the power of the CDC to Kafka to Snowflake pipeline for building modern, real-time data architectures. Finally, we discussed how to handle crucial aspects like schema evolution using tools like Schema Registry and Snowflake's variant type, and how to ensure pipeline resilience through monitoring dead letter queues and ID impotency. CDC truly empowers your data engineering efforts with agility and real-time capabilities. Thank you so much for joining me on this deep dive into change data capture. I hope you found this tutorial informative and helpful. Keep learning and growing with data engineering with Subhadip. If you enjoyed this video, please remember to like, share, and subscribe for more insightful data engineering content. See you in the next video.